5 students are asked to randomly select and name a polygon from the group below. What is the probability that the first 2 students choose the triangle and quadrilateral in that order? So, right off the bat, is this going to be a permutation or a combination? It's a permutation, okay? Because the order that we pick the things in matters. So really what I want to know is, out of those 5 students, how many different arrangements are there where I could have 2 of the students come up and pick the triangle and quadrilateral? So how would I set that up as a permutation? It would be what choose what? Or what P what?
Would it be 5?
5P2. Yep. What this is going to tell me is, if I were to draw these 5 shapes on the board, and then I were to randomly select 2 students to come up to the board and pick one, how many different groups of 2 students there could be? Okay? How many different ways I could pick 2 students? And because I want the first one specifically to choose the triangle, and the second one specifically to choose the quadrilateral, it would be different if I called Cameron and then Lexi than if I called Lexi and then Cameron. So I want to count all of those combinations separately. Travis?
How do you find P on this?
On that calculator, you want to look for a button that says PRB, for probability.
Oh, I got it.
Okay? And then when you hit that, it's going to give you should find NPR in there somewhere.
Yeah.
So you would type in 5,
NPR.
NPR 2.
Also the same thing. I know that's the same thing.
Yep, so what do you get when you do that?
20.
20. Okay, so there are 20 different ways that I could choose 2 students to come up to the board. Now I want to know, what is the probability that the first 2 students, so that's one of those groups of 2. So my probability, there's 20 different ways I could call up students to pick those shapes. What's the probability that it's the first 2? That would be one of those groups of 20. Or one of those groups of 2. One of the 20 groups of 2 is the way I want to say that. So the probability would be 1 out of 20. That's one way to think about that one. There's another way to think about that one too. So if that didn't make sense to you, hold tight, because I'm going to show you a different way to think about it. Okay? The way I did it, and this sort of matches up with, there was one in your notes, I don't remember which one it was, but the way I thought about it is I said, okay, I want to figure out how many different ways are there that I could call the 5 students to the board. How many ways are there that I could arrange the 5 students? So there would be 5 students to choose this one, 4 students to choose this one, and so on, right? Does that make sense?
Yeah.
So when I multiply that together, I believe that gives me 120. And that's 120 total ways that the 5 students could choose their I keep saying this wrong. There's 120 ways that those 5 students could arrange themselves and choose the polygon. Okay? Now I want to know how many of those 120 ways would have the first student choosing the triangle and the second student choosing the quadrilateral. Well, that means I'm locking in this one. There's only one possible student that can pick that triangle. And there's only one possible student that can pick that quadrilateral. Okay? I want the first person to take this one and the second person to take this one. So now how many students do I have left?
3.
3, right? And I can arrange those 3 students on these other 3 any way I want. So there's 3 students that could take this one, 2 students that could take this one, and 1 student that could take this one. When I multiply those together, I get 6. So out of those 120 different ways I could arrange my 5 students, 6 of those ways would have the first student taking this one and the second student taking this one. So I would line this up as 6 out of 120, which, right, if you were to divide that and turn it back into a fraction, it would turn back into 1 out of 20. Okay, so you get the same answer either way. Whether you want to think of that as you have 5 students and you're choosing 2 of them, or whether you want to think of it as how many total ways could I arrange all 5 students, and then how many of those ways would have the right students where we want them to be. Does that make sense? All right, read number 2. Is number 2 a combination or a permutation?
Oh, a combination.
Why do you say that?
These random order does not matter.
Okay. I agree with you that the order that I choose the students does not matter. But let me show, and
Oh, never mind, it is.
Okay.
I didn't read all the way through.
okay, that's okay, but it's a good point to make. When I say order matters, that's sort of an oversimplification, because it's not always necessarily order that matters. What I'm really asking is, if I choose these 3 students, and I were to arrange those 3 students in a different way, would that count as a different arrangement? So I want to choose Chase specifically for lighting, I want to choose Jaden specifically for props, and Emelina specifically for spotlighting. If I chose those 3 students but gave them different jobs, is that okay? No. So that's why this would be a permutation.
I didn't read all the way through.
That's okay. That's okay. It's a point that I wanted to make to everybody. I'm actually glad you said that. So I have how many students? 18. I'm going to do 18
NPR.
P3. Yep. So 18 NPR3. Help me out with that. Need help finding the NPR? Okay. So you're going to type 18 under the math menu. There's probability, and then it's the second one. Okay. Yep, 18 NPR3. Okay.
4,896.
Thank you. So I have 4,896 different arrangements. So if I am selecting a student for lighting, a student for props, and a student for spotlighting, out of those 18 students, I have 4,896 ways that I could make that selection. What is the probability then that this is the selection I come up with? There's one possible one that I want. So 1 out of the 4,896 would be my probability. So like I said, as I was walking around, I saw a lot of people had that number, but you want the probability that it's this specific group. Okay, number 3 is a permutation with repetition. And I gave you a special formula for that. Okay, there are some other ways to calculate this, but the formula I would use here is I would say, how many things do I have total? I have 7 of them. And then I want to get rid of my duplicates, because my duplicates would really look the same way. So if I just wanted to know how many total ways could I arrange these 7 things, that would be 7 factorial, right?
Yeah.
Okay. But when I make those 7 factorial arrangements, if I were to put this F here and this F here, or if I were to switch the F's, I would still want to count that as really the same arrangement, right?
Yeah.
So I want to take out however many duplicates I get. So I have 2 F's, so I'm going to put 2 factorial under here. What else do I have that's a duplicate?
3 3.
I have 3 3, so I'm going to put a 3 factorial under here. So I want to do 7 factorial divided by 2 factorial and 3 factorial. Probably going to have to put that in parentheses in your calculator. What did we end up with?
420.
Say it again. 420. So there are 420 distinct arrangements, which means there are 420 ways I could lay those things out and have them look different from one another. So I'm not counting it as a different arrangement if this F and this F are reversed. Okay? So there's 420 total. I want this one specifically.
So 1 out of 4.
Yep, so probability is 1 out of 420. Making sense?
Yeah.
Okay. I told you to skip number 4. So if you weren't here, skip number 4. We're not doing the circular ones. Okay. 500 boys, including Josh and Saka, entered a drawing for 2 football tickets. What is the probability that those 2 boys won the tickets? Is this a permutation or a combination? Why? Okay, so it doesn't matter if we pull Josh's name first and then Saka's, or Saka's name first and then Josh, because they're both winning football tickets. Now, if we were giving like specific seats, and we were saying this person wins this seat and this person wins another seat, then I would say the order matters. But if it's just I want, excuse me, if it's just that I want to pull those 2 names out of the hat, it doesn't matter whether I pull them out this way or this way. Bryce?
Would you do the 500 NCR
Yep, 500 C2 or 500 NCR2.
That equals 124,750.
Okay. So out of the 500 tickets, or out of the 500 boys, there are this many ways to pull two names. Okay, there are this many different combinations of names. How many of those combinations would be these two?
One.
Just one combination, yeah? So the probability would be 1 out of that. Okay? Number 6 is another one that I would kind of go through. There's two different ways to go through it. Okay? Nia and Chad are going to a concert with their high school's Key Club. If they are choosing a seat in that row at random, what is the probability that Chad will be in seat 11 and Nia will be in 12? Bryce?
Permutation.
Okay, this one is a permutation because we want them in specific places, right? And I don't care where everybody else ends up. Really what I'm trying to find out is how many different ways are there that I could choose 2 students for these 2 seats? Okay, how many ways are there that I could, out of those 12 kids that are going, how many different people could I put in those seats? So how am I going to set that up?
12 and NPR 2.
12 NPR2, yep.
That equals 132.
132. Okay, and out of those 132 different arrangements, how many would there be
One.
where Chad is here and Nia is here?
One.
Just one of those, right? So the probability is 1 out of 132. Okay. Again, this is one where I actually would probably go about it a different way. Okay. You guys all with me?
Yeah, no matter.
Okay. Another way you could think about this is sort of like we did the polygon one on the front. First, I would say to myself, how many different ways are there to arrange all 12 students? How would I figure that out?
You would do the combination because order wouldn't matter.
Not quite. Like, if I were arranging all 12 students, how many students are there that could go here?
Oh.
12, and then 11, and then 10, right? So that would be 12 factorial. Okay, 12 factorial gives me the number of ways that I could arrange all 12 students. Now, if I say I want Chad in this seat, there's only one possible person I can put there. And if I want Nia in this seat, there's only one possible person I can put there. So how many students do I have left?
10.
And so for the rest of the seats, I have 10 students that could go here, 9 here, 8 here, 7 here, and so on, right? So what's that really going to equal? How would I calculate that?
Would you do the 10 factorial?
That's going to end up being 10 factorial, yep. So there would be 10 factorial ways to arrange everybody else. Okay, if I put Chad and Nia in the seats we want them, there's 10 factorial ways to get everyone else around. So 10 factorial divided by 12 factorial. Go ahead and do that for me and convert it back to a fraction. Can you make that into a fraction? Hit math and then fraction. You got it, Travis?
Wait, no, I have a question.
Okay, yeah.
I didn't.
Oh,
Never mind.
You okay?
okay, looks like I got it.
Okay, just like this, right? We got 1 out of 132. Travis?
I did like 12 factorial divided by 10 factorial, and then I got 132, and then.
Okay. The reason is, yeah, when you divide it the other way, really, it's supposed to come out as 1 over 132. When you flipped it, you made it 132 divided by 1.
Oh.
So I guess you could do that if you knew in your head to flip it, but mathematically that doesn't really make sense, but that's fine. Yeah, you can do that. Bryce?
When I did the fraction of 0.0075, I got 3 out of 400.
Okay, but did you use the decimal that your calculator had there, or did you retype it and round it off? Okay, the rounding is what did that. It should be, that fraction is actually probably pretty close to this. Okay, Travis?
Can I turn the fan off?
Yeah, sure. Okay, couple more to get through. It's a little round button on the front. Alfonso and Colin each bought one raffle ticket. There were 50 tickets sold. What is the probability that Alfonso got number 14 and Colin got number 23?
Permutation.
Permutation or combination?
Permutation.
Permutation, because we want them to get specific numbers.
50 FTR.
There you go. 50 P2.
20,
What's that one going to be?
2450.
Okay. And out of those 2,450 different arrangements, how many would be with Alfonso here and Colin here? One of those, yep. So the probability is 1 out of the 2,450. Okay. What's the difference between Part A and Part B on number 8?
Number 1 is
Number 1, A is going to be a permutation.
Okay.
combination. Because it doesn't matter which way they go.
Right. Rihanna, what were you going to say? Just that? Okay. Yep.
And
In A, the gymnasts are performing in any order. That tells me this is a combination. Okay? In B, we want Cecilia first, Annie second, and Kimmy third. So I have how many gymnasts? 7, I think?
7.
Okay. So first I want to figure out, if I just take my 7 gymnasts and I were to pull a group of 3 of them, how many different groups of 3 could I get? So that would be 7C3
35.
is 35. And so there would be 1 out of 35 chance that the group of 3 I pull are these 3 girls, Cecilia, Annie, and Kimmy.
It would be 17.
Right. Now this one wants me to not only pull those 3 girls, but it wants them to be in that order. So if I were to pull those same 3 girls, but I had Kimmy first and Annie second and Cecilia third, that would not count. That would not be okay. So now I'm doing 7P3, and I think I get 210.
Correct.
And so now my probability is 1 out of 210. Because what I really want is this specific order. So again, if I were to pick one of these other ways where the girls are in a different order, that wouldn't count, you know, as one of my ones that I want. Does that make sense? Questions on that? Do you feel better about that assignment now a little bit? I hope. Okay.